Now let's solve integrals using identities. Now an identity states, there is one identity that states that if you have an integral in which the denominator has a function and the numerator has the derivative of that function, it will result in basically the natural log of the actual function, so f of x, and the constant of integration as well. Now you can see that over here the numerator is not exactly the derivative of the denominator, but we can turn it into 1, and you can do that by basically multiplying the numerator with 2, which is why you have this now. And you'll also have to divide this entire integral with 2 as well, so you'll multiply the entire thing with 1 by 2 so that they can cancel out and the overall value of this entire thing remains the same. Now you can see that the denominator and the numerator is now indeed the derivative of the denominator. The derivative of ax² is indeed 2ax, the derivative of 2bx is indeed 2b, and the derivative of c, which is a constant, is just 0, so 0. Now you can apply this identity, and so you will have the natural log of this denominator multiplied with this 1 by 2, and so you have this. And as you can see, you'll have to differentiate this constant with the constant of integration, so you'll write down the constant of integration as c1 instead of c. Now you have this integral over here. Now the way to solve this is basically you can use a trigonometric identity which states that basically tan² x is equal to sec² x minus 1. So you'll replace this tan² x with sec² x minus 1, and hence you have this. Now you can apply the integral separately on sec² x and minus 1. So this is what you get. Now this just results in basically x, and the integral of sec² x is just tan x, and these are some things that you have to memorize or they will be given to you, but you don't really need to know the proof right now. And obviously the constant of integration as well. So this is the use of the trigonometric identities to solve integrals.